Tonight, we're looking into posts being spread on social media. They claim the James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth.
Proxima b might have just changed everything we thought we knew about life beyond Earth. James Webb just delivered the clearest, most detailed look yet at this mysterious world, and what it found is nothing short of astonishing. Let us dive deeper, because what comes next could shatter everything we know and challenge our beliefs. JWS uncovers Proxima b's secrets. The James Webb Space Telescope didn't just snap a picture. It's also studying Proxima b's atmosphere, analyzing the gases to look for biomarkers, those chemical signs that scream life. This is where things could get really wild. If it finds methane or oxygen in the right amounts, that's a huge indicator that something, or maybe even someone, could be living there. But here's the part that will keep you on the edge of your seat. The initial data has shown something unexpected. What could it be? The idea of a habitable planet around a red dwarf is controversial. There are people pointing out that the constant radiation from Proxima Centauri's flares could be a deal breaker. Even if there's water, even if there's an atmosphere, that radiation would make life as we know it nearly impossible. But then again, what if life on the planet isn't like life on Earth? What if it's adapted to those harsh conditions in ways we can't even begin to imagine? Some scientists are suggesting that if there is life there, it might not be anything like what we'd expect. It could be more like bacteria, toughing it out under the planet's surface, shielded from the radiation. Or maybe it's something else entirely, something that doesn't need the same protection we do. It's a lot of what ifs, but that's kind of the point, isn't it? The universe is full of surprises. The planet isn't alone. It's part of a star system, with other planets orbiting Proxima Centauri too. There's Proxima Centauri c, a larger planet that might also have some interesting secrets to reveal. The whole system could be teeming with things we've never even thought to look for. Projects like Starshot are looking into how we might actually get there. Right now, it'd take tens of thousands of years to reach Proxima Centauri with our current technology, but Starshot wants to change that by using powerful lasers to propel tiny spacecraft at a significant fraction of the speed of light. If they can pull it off, we could send a probe and get pictures and data back within a few decades. It's still a massive long shot, but it's a lot more realistic than it used to be. Imagine what it would be like if, within our lifetimes, we actually made contact with an alien world. If we found life, even microbial life, it would completely change how we see ourselves and our place in the universe. We'd no longer be alone, no longer the sole intelligent beings in this vast, dark cosmos. And what if it's more than just microbes? What if there's something out there that's aware of us, that's looking up at their sky and wondering if they're alone too? History tells us that first contact scenarios don't always end well. We've seen it time and time again here on Earth. When two civilizations meet, the outcome is rarely peaceful. If we do make contact, we've got to be smart about it. We've got to consider what kind of message we're sending, how we present ourselves. Are we explorers looking to share and learn? Or are we invaders, taking what we want without thinking about the consequences? If there's even the slightest chance that the planet is home to life, we're going to keep looking. The James Webb Space Telescope has only just begun its mission, and already it's turning everything we thought we knew upside down. The universe is full of secrets, and this planet might just be the first of many that we finally get to unravel. The planet orbits its star in just 11 days, a much faster year than what we experience on Earth. This means that it is much closer to Proxima Centauri than Earth is to the Sun. But since Proxima Centauri is a red dwarf, it's much cooler, allowing the planet to sit in the habitable zone despite its proximity. This also means that it is tidally locked. One side always faces the star while the other remains in perpetual darkness. This kind of setup creates extreme conditions, with one hemisphere constantly heated and the other frozen. If there's life, it's probably huddled in the narrow twilight zone between these two extremes, where temperatures might be just right for liquid water. The atmosphere, if it exists, would have to be resilient to withstand the constant battering from solar radiation. Scientists think that a magnetic field, similar to Earth's, could help protect the atmosphere from being stripped away. Without it, the planet might be a barren, rocky world, devoid of air and water. But if it does have a magnetic field, that changes everything. It means there could be a stable environment where life could take root. This is why the James Webb Space Telescope's ability to analyze atmospheres is so crucial. By studying the light that passes through the planet's atmosphere as it moves in front of its star, scientists can determine what gases are present. They're looking for things like oxygen, methane, and carbon dioxide gases that, on Earth at least, are associated with life. If they find these gases in the right proportions, it could be the evidence we need to prove that we're not alone. But even if we don't find life, the planet is still an incredible discovery. It's a chance to study a rocky planet in the habitable zone of another star, something we've never been able to do before. It's a window into a completely different world, one that could help us understand more about the formation and evolution of planets, including our own. The more we learn about this planet, the more we learn about the possibilities for life elsewhere in the universe. Proxima b shows promise, but its star poses a big threat. Can life survive these harsh conditions? Facing deadly flares and harsh radiation, the Starshot project is one of the most ambitious ideas out there for exploring the planet. The plan is to use powerful ground-based lasers to accelerate tiny, lightweight probes to about 20% of the speed of light. At that speed, the journey to Proxima Centauri would take just over 20 years. The probes would be equipped with cameras, sensors, and communication equipment, allowing them to take pictures and gather data, which they would then send back to Earth. It's a bold idea, and there are a lot of technical challenges to overcome, but if it works, it could revolutionize our understanding of the universe. The biggest challenge is the sheer distance. Even at 20% of the speed of light, it would take over 4 years for a signal from Proxima Centauri to reach us. That means any data collected by the probes would take a long time to get back to Earth. And then there's the problem of aiming the lasers precisely enough to hit a target that is trillions of miles away. But the potential payoff is huge. For the first time, we could get a close-up look at another star system, complete with its planets, and maybe even find signs of life. The discovery of the planet has also reignited interest in the search for extraterrestrial intelligence. If there is a civilization there, they might be trying to communicate, just as we are. Projects like SETI, Search for Extraterrestrial Intelligence, are already listening for signals from Proxima Centauri, hoping to pick up anything that might indicate intelligent life. So far, there's been nothing conclusive, but the search is just beginning. And even if we don't hear anything, that doesn't mean no one's out there. It might just mean we need to listen harder or in different ways. The idea of making contact with an alien civilization is both thrilling and terrifying. On one hand, it could be the most profound discovery in human history. It would mean that we're not alone, that there are other beings out there, looking up at the stars and wondering about their place in the universe, just like we do. On the other hand, it's impossible to know how such a civilization might react to discovering us. Would they be friendly, or would they see us as a threat? Would they want to communicate, or would they prefer to be left alone? The planet is much older than Earth, which means that any life there could be far more advanced than we are. They might have technology that we can't even begin to understand, or they might have moved beyond technology altogether, evolving in ways that are completely alien to us. It's also possible that they're a young civilization, just starting to explore their star system, much like we are. Or they could be long gone, wiped out by some catastrophe, with only the ruins of their civilization left behind. The possibility of finding life there forces us to confront some big questions about our own future. If we do find evidence of an advanced civilization, what does that mean for us? How would we handle it? Would we try to make contact, or would we decide that the risks are too great? And if we did make contact, how would we communicate? What would we say? These are questions that scientists, philosophers, and policymakers are already grappling with, and there are no easy answers. One thing is certain, the discovery of the planet has changed the way we think about the universe. It's a reminder that we are just one small part of a vast, complex cosmos, and that there is still so much we don't know. Whether or not we find life there, the search itself is worth it. It pushes us to explore, to learn, to reach beyond what we know and to imagine what might be possible. And who knows? Maybe one day we'll look up at the night sky, point to a distant star, and know that someone is looking back. This star isn't just spitting out a little extra light now and then. We're talking about explosions that crank up its brightness by over 60% in just a few minutes. This kind of flare-up isn't rare either. It's like Proxima Centauri has a serious anger issue, constantly blasting the planet with intense radiation. Now, you'd think being in the so-called habitable zone would mean something good. Not too hot, not too cold, just right for liquid water to exist. But when your star keeps exploding on you, that habitable label becomes a bit of a cruel joke. The planet orbits so close to its star, about 5% of the distance between Earth and our Sun, that it's getting roasted with ultraviolet and X-ray radiation. We're talking about 10 to 60 times more radiation than what we get here on Earth. It's like being at the worst beach party imaginable, with a sunburn that never ends. And this isn't just bad for your skin. It could strip away the planet's atmosphere entirely, leaving it dry, lifeless, and barren. And then there's the ultraviolet radiation that breaks water down into hydrogen and oxygen. The hydrogen, being the lightest element, escapes first, which means the planet could end up as dry as the Sahara. It's not just the water we have to worry about. The entire atmospheric balance could be thrown off. Imagine the protective ozone layer, which shields us from ultraviolet rays, getting ripped apart by this intense radiation. Without an ozone layer, any life on the surface would be completely exposed to deadly radiation. Not exactly the kind of place you'd want to plan a vacation. There's still a chance, however slim, that the planet could be holding its own against all this chaos. If the planet has a magnetic field strong enough, it might work like a force field, protecting the atmosphere from being blown away. Think of it as an invisible shield, similar to Earth's magnetic field that keeps us safe from our sun's solar flares. Plus, if the planet has a really thick atmosphere, it might absorb some of that radiation, spreading the heat out so it's less of a planet-wide barbecue. Even with all these challenges, scientists aren't ready to give up on the planet. Its proximity to us makes it one of the best places to look for life outside our solar system. As our technology improves, telescopes like James Webb and others on the horizon could give us a closer look at what's really going on there. We might be able to determine if there's an atmosphere, what it's made of, and if there's any chance of liquid water, a key ingredient for life as we know it. Even with the radiation, there might be hope below Proxima B's surface. Could underground water be the key? Life potential in Proxima B's underground water. Finding out if Proxima B is habitable isn't going to be easy. Just being in the habitable zone doesn't mean much when your star is a raging red dwarf with a habit of blasting you with radiation. We've got to consider so many other factors: the star's behavior, the planet's atmosphere, magnetic field, and even how it rotates. All these things make a difference in whether or not life could survive there. And let's not overlook the fact that the planet might have liquid water, even if it's underground. Subsurface water is one possibility that could change the game entirely. If there are underground lakes or oceans, they could provide a stable environment for life, shielded from the harsh radiation on the surface. We've seen similar things here in our own solar system. Moons like Europa and Enceladus have subsurface oceans that might harbor life, despite being bombarded by radiation from their respective planets. The planet could be hiding something similar, and it's worth investigating. On Earth, our magnetic field is generated by the movement of molten iron in our planet's core. This field acts like a protective bubble, shielding us from the worst effects of solar wind and radiation. If the planet has a similar setup, it might be able to fend off some of Proxima Centauri's violent flares. However, for a planet so close to such an active star, that magnetic field would need to be incredibly strong, and there's no guarantee it even has a molten core to generate that kind of protection. Another thing that could help the planet stay habitable is a thick atmosphere. Think something like Venus. Venus has an incredibly dense atmosphere that helps redistribute heat across the planet, which is why it doesn't have extreme temperature differences between its day and night sides. If the planet has a thick enough atmosphere, it could help moderate the temperature differences between the side facing the star and the side in perpetual darkness. This kind of atmospheric circulation could create pockets where life might have a chance to survive. But let's not sugarcoat it. The planet is in a tough spot, even with a magnetic field and a thick atmosphere. The radiation from Proxima Centauri is relentless. High-energy particles could still penetrate the atmosphere, causing all sorts of problems for any potential life. And the constant barrage of flares means that conditions on the planet are probably anything but stable. Imagine trying to build a house in a place where hurricanes, tornadoes, and earthquakes happen every single day. That's basically what life on this planet would be up against. Still, the potential for life, even microbial life, is enough to keep scientists interested. We're developing new ways to study exoplanets, and this planet is a prime candidate for future missions. The idea of sending a probe to Proxima Centauri has even been floated around. With technology like Breakthrough Starshot, which aims to send tiny, light-propelled probes to nearby star systems, we could get a closer look within our lifetime. Imagine the discoveries we could make if we could actually see the surface of another planet up close, especially one that might have the conditions, however challenging, to support life. The planet also offers us a glimpse into what planets around red dwarfs might be like. Red dwarfs are the most common type of star in our galaxy, which means there could be billions of planets out there facing similar challenges. By studying this one, we can learn more about the kinds of environments that might exist throughout the Milky Way and refine our search for truly habitable worlds. Maybe this planet isn't the perfect candidate for life, but it's teaching us how to look at other planets in a more nuanced way. And let's not forget the possibility of underground life. If the surface is too hostile, there's always a chance that life could be thriving below ground, where it's shielded from radiation and has access to water and nutrients. On Earth, we've found entire ecosystems miles below the surface, living off chemical reactions rather than sunlight. If something similar is happening on the planet, we could be looking at a completely different type of biosphere, one that doesn't rely on the surface conditions at all. The search for life beyond Earth has always been full of surprises. We've learned that life is incredibly resilient, capable of surviving in some of the harshest conditions imaginable. Whether it's bacteria living in radioactive waste, organisms that can withstand the vacuum of space, or creatures that thrive in boiling hot springs, life finds a way. If there's even a tiny chance that the planet has the right conditions, it's worth exploring. And even if we don't find life, we'll still learn something valuable about the nature of planets, stars, and the delicate balance that makes a world habitable. The planet might not be the idyllic, Earth-like world we'd hope for, but it's still one of the most intriguing places we know of outside our solar system. It's close enough for us to study in detail, and it's teaching us a lot about what makes a planet habitable or not. The challenges it faces are extreme, but they're not insurmountable. Life, if it exists there, would have to be tough, adaptable, and resourceful, qualities that make the idea of alien life all the more fascinating. Could life thrive on Proxima b despite the relentless radiation? Drop your thoughts in the comments and don't forget to like and subscribe for more cosmic explorations.